You should be somewhat familiar now with graphing linear equations, especially when they say y equals 2x minus 3, y equals 1/2 x minus 4, anything where it says y equals. Well, sometimes lines are written in different forms, so what we're going to do is practice if it's not in y equals form. So at the end of this lesson, you'll be able to graph a linear equation that is not written in y equals form using the intercept method. Right, so what do you do if your equation isn't in the form y equals mx plus b? We are going to be, the answer will be find the intercepts, intercepts, then graph the intercepts. Okay, and by intercepts, we're looking for where does the graph touch the x-axis and where does the graph touch the y-axis. So in this first example, it says graph 2x minus 7y equals 14. Notice it doesn't say y equals. It's still going to be a line, but it's just not in the right form that we're used to. So I am going to, first of all, write that another time because we're actually going to be dealing with an x-intercept and a y-intercept, so we need two equations. So the first thing that I'm going to do is find the x-intercept, which is where does that graph cross the x-axis? Well, if it crosses the x-axis, the y value would be 0. So we're just going to scribble out the y value because that's just going to become 0. And then I'm just going to write what I have left. I have 2x equals 14. And then I'm going to solve this for x, and if I do that, I'll divide both sides by 2. So we've got x equals 7. And that means that this line crosses the x-axis at 7. So I'm going to go over to 7 on the x-axis, and if you would like to label your x and y before we get started, that's always a good idea as well. Okay, so I found the x-intercept. Now to get the y-intercept, we're just going to let the x value be 0, because that would be true. That would the x part of the point would be 0. Okay, now I'm going to write what I have left. I have negative 7y equals 14. And then to solve this for y, we would divide both sides by negative 7. So I'm going to get y equals 14 divided by negative 7 is negative 2. So that means that this graph touches the y-axis down at negative 2. So I'll put a dot there. Now remember, we know it's going to be a line because we're dealing with a linear function. So now all I need to do is go ahead and connect those 2 points, and we have our equation of our line. All right, let's try another one. This next one says x minus 2y equals 8. Again, it's not written in the proper form, so we're going to find the intercepts. I'm going to write that equation again, and I definitely would like you to get in the habit of doing that as well. So to find, and I'm also actually going to label my x and my y axis just so I don't get those confused. And then what I'm going to do, first of all, I'm going to find the x-intercept, so I'll let the y value be 0, just cross that right off, and I'm just going to write what I have left. I have x equals 8, and there we go, x equals 8, I found it. So on the x-axis, the graph touches at 8. 1, 2, 3, 4, 5, 6, 7, I need to go one more, so about right there. Okay, and then for the other one, if we want to find the y-intercept, we're just going to cross off the x. We'll let that be 0, and I'll write what I have. I have negative 2y equals 8, and then to solve for y, we'll divide both sides by negative 2. So y will equal 8 divided by negative 2 is negative 4. So this graph touches the y-axis down at negative 4. And then once again, we're just ready to go ahead and connect the graph, and we got it. All right, on question number 9, I'm going to let you go ahead and pause the video and try it on your own and then come back and see if you got the right answer. All right, hopefully you're back and you're ready to find out if you did it right. I'm going to, once again, 3x plus 5y equals negative 15 is not in y equals form, so I'm going to write this equation again. And then for the first one, we'll cross off the y. We'll let the y be 0, so I have 3x equals negative 15. To solve for x, we'll just divide both sides by 3, and I'll get x equals negative 15 divided by 3 is negative 5. I'll label my axes here, x and y. So I know that my graph crosses the x-axis over at negative 5. So I'll put a point there. And then my other one will let the x value be 0, and I'll get 5y equals negative 15. To solve this for y, we'll divide both sides by 5, and I'll get y equals negative 15 divided by 5 is negative 3, so I know it touches the y-axis down at negative 3. And then we can just go ahead and connect those 2 points. Whoops, sorry about that. All right, and so once again, I have the equation of the line. So hopefully now you can graph a linear function that is not written in y equals form using the intercept method.